So we're going to solve this equation. Negative 3/4 y plus 9 equals 2/3 y minus 5. Let's go ahead and get started on this one. And a couple different ways to do this, but I'm going to stick to the way that we did it last time in class, okay? Let's make this a little bigger. Now, there are other ways to do this. Okay, some of you guys have heard of this. Can we make the denominators all the same? Yes, you can. It's just proven perilous in the past, so I tried to avoid it. Okay, so I'm just, if we can work with fractions, which your calculator will do. So, let's go and make some big decisions right here, right? Like a Bob Ross painting, putting trees in front of everything. I want the y's, because most people prefer the y's on the left. Okay, so I got my y's on the left, numbers on the right, okay? Now, I put those labels there. They don't mean anything other than I know where stuff should go, right? So I'd say, look, here's my term, negative 3/4 y. It's on the correct side with the y's, right? But I got plus 9. It doesn't have a y. It's not a y term, so it has to, well, it has to zero out. So how do I zero out a plus 9? Subtract 9. But if you do it to one side, you should do it to the other side. Some of you guys are worried because you may have put the y's on the other side of the equal sign. It still will work. You'll see. Right? Or you may have subtracted something else first, and that again, it should still work. I'm doing this one at a time, so let's move from left to right here. I'm going to go and drop this negative 3/4 y. Of course, those 9s, 9 minus 9, that zeroes out. So again, I'm not circling it. That's an actual 0. This will equal, is drop the 2/3 y. And then we have the final operation here. That's negative 5 minus 9, which is negative 14. Of course, that reads minus 14, but it's a term, negative 14, okay? So now, I don't have any other non-y terms on the left side. But now I do have a y term on the number side of thing, okay? So I got to zero that out. How do you zero out 2/3 y? Just subtract it from itself. Remember, when we want to create 0, we use the addition or subtraction principles of equality, right? So subtract 2/3 y, and there's our equal sign there. So that does zero out. Anything subtracted from itself zeroes out. Negative 14, let's go and drop that, negative 14. And then I got negative 3/4 y minus 2/3 y. Oh, geez. Let's do this here on the left, okay? So I'm going to do it by hand. I know some of you guys got calculators, but I just forgot mine. I guess I could pull one up. Negative 2/3. Why am I not including the y's? Because they're both y terms. I'm going to end up with some number of y's no matter what. Okay? So I got negative 3/4 minus 2/3. Once again, I'm going to use that same strategy of forcing the denominators to be the same because I am subtracting, so I do need them to be the same, like we saw before. So I'm going to multiply the 3 denominator into this first fraction. That's going to be negative 9/12. I'll still keep the subtraction. But then we'll multiply the 2 and 3 by the other denominator 4. So that ends up being 8/12. See, and that forced the denominators right away to be the same. Is it the lowest common denominator? No, but all we really need is common denominators. It doesn't have to be the lowest. Okay, so when I combine these, I should be looking at 12ths, no matter what. It's just how many 12ths is it? Well, you got negative 9 minus 8 of the 12ths, so that should be negative 17/12. So what do we see here? We got negative 17/12 y equals negative 14. No problem, man. We can, we can divide both sides then by the coefficient, negative 17/12. It will need more space, but negative 14 divided by negative 17/12. Well, you know what? I'm going to use a calculator on this one. But first, coefficient of y is a phantom 1. This equals, there we go. I can pull one up.
12ths?
Bam. 168/12. 17ths.
17.
There we go. That's better. I'll try to remember my numbers better. Now, how do I know this is simplified? Because that's what the calculator pushed out. So if it would needed to be more simplified, it would have. It would have done it. In fact, some of you may know how to change the improper fraction here to a mixed number. I don't care. We don't need to because, like I said, the section should want pretty much all the answers as improper fractions there.